Last month, I'd mentioned I'd provide more details on Exploring Tour. So, as hopefully you're all aware, our flagship event is in Las Vegas, 25th to the 28th of August. Registration details are available on the Explore website, which I'll put into the chat later. And we're running local explores. So, Explore on Tour in London is on the 17th to the 18th of September. I can tell you it's going to be in the Hilton London Metropole. Cost will be £150, and that will include the usual food and drinks throughout the day, the backpack, and the option for a free certification. So if you've been planning on doing a cert sometime this year, I'd really consider whether you want to try and do it as part of Explore on Tour. So hopefully that means if you've not been able to be able to attend and explore before, you'll be able to do it now, obviously in country at a significantly lower cost. So feel free to ask any questions in the Q&A as we go through the sessions. We've got moderators backstage who are going to help answer as many of those questions as we can. So Chris, please introduce yourself and kick us off.
Thank you, Carl. Good afternoon, everybody, or good evening, or whenever the time is when you're watching the playback. Um, so let me just switch screen. Here we go. Good afternoon, everybody. Sorry, my name's Christopher Lewis, and I work within the VCF specialist team within the UK and Ireland. And before I formally introduce myself, I always like to think that a good presentation starts with a disclaimer. And so here's my disclaimer that says lots of things I talk about today are already there in the product. But obviously we're imminent, looking at a sort of the future from a VCF9 perspective. So hopefully I won't mention anything, but if I do, it may or may not happen. So that's my disclaimer sort of set there, essentially. So just by way of introduction, as I said, Christopher Lewis, I work in the UK&I specialist team. I've worked for VMware now for around about 6 years. Do lots of different things as well as my day job. Supporting the sort of pre-sales motion of our sort of VCF product set, a certification, SME, and a hands-on labs principle as well. Hopefully, everybody has used hands-on labs before. But hopefully you'll get at the end I've got some links to hands-on labs, which, and when you get the presentation deck, if you can download it, then you'll get those links as well. I wanted to start off sort of, we're here to talk about capacity planning and the chaos that can be caused by that. And really, from an operations perspective, there's sort of four key things we look at when we talk about capacity planning. We talk about assessment, reclamation, right sizing, and then forecasting for the future. And so we're going to go through each of those. I'm going to hopefully, if the technology sticks with me, I'm going to do most of it via demo. But I do have some backup slides if I need to as well. But before we start going into the demo, what I always find useful is to talk about the basics around capacity planning from a VMware perspective, or a VMware by Broadcom perspective. So what I've done is sort of put some definitions together so that we can talk through, or very quickly go through those. And on the right-hand side of the screen, you'll see the sort of the green is where typically we look at this sort of metric, but it does the lighter blue is where you can also see them as well. But they tend to be either boiled up to those particular metrics, but they tend to be centered on the things that I've highlighted in green. So the first metric, or the first sort of thing we talk about, is total capacity. So how much of capacity do I have in an environment? And typically, when we're doing capacity planning, we talk about it at a cluster level. But again, it can be boiled up into a data center or in a vCenter or in what something we call the vSphere world, which is the sort of the top level metric set within our operations. These terms we'll be using throughout the session, so it's good to sort of get them out of the way to start with. Then we have overhead. Overhead is essentially the resources required by a workload or by virtualization in general to on the hypervisor to run virtualization. So that could be memory overhead, could be a little bit of CPU overhead, but that comes into consideration when we're talking about the capacity and what's made up of the total capacity. We then have HA. Now, HA is more of a calculated metric than an actual metric that we collect, but essentially that's the um, amount of capacity reserved by vSphere HA. So if you don't have vSphere HA enabled at sort of a cluster level, then that would essentially be zero. But typically most people have a HA and a DRS cluster, and so that capacity is reserved against the usable capacity, which we'll get to in a second. You then have something called a buffer, and a buffer essentially is being able to say as an organization, I want to make sure that I have 20, 30, 40% available on capacity available for those peak workloads that I can't forecast. So the unforecasted peak workloads that may happen because of an event that's happening that you don't think is going to cause a massive issue, but you want to be able to make sure you've got that little bit of buffer to be able to make sure that your workloads can use more than they would normally, but not affect everything in the cluster or in the data center. You then have usable capacity, and usable capacity after HA and buffer is essentially the total capacity, taking away what we've allocated for HA and for buffer. So that usable capacity is there. And then you have, and that tends to be again on a sort of like a cluster level. And then utilization can be on hosts or virtual machines, again, rolls up into clusters, but that's essentially how much capacity, whether that be CPU, memory, or disk, does that workload currently receive or consume of the resource capacity that's there. Then we have demand, which is how much is the virtual machine or the workload asking for, because those two can be different. Demand can be, I might be demanding so many megahertz, but actually because of contention I might not be able to get that amount of megahertz. I might be able to only have 75% of what I'm asking for. So, and that's where sort of contention comes into it as well. So the contention is the difference between what I'm requesting and what I'm getting. Hopefully that's all clear. Um, so when we're looking at assessing capacity, we tend to look at it at a data center level, a very high level, and then we start to look at it on a cluster by cluster basis to make sure we have capacity. It's very difficult to look at it a host by host basis because really holistically, if you've got workloads that are using too much capacity on a host, they need to be able to move to a different host within the cluster. So therefore, we look at it at a cluster level. Now, um, we take those metrics that we've talked about, typically, specifically the utilization and the demand metrics, um, and the usable capacity metrics. So that's the not the total capacity, but the usable capacity, and they get fed into our analytics engine or capacity engine. And essentially, what comes out of that is from a capacity perspective, how much time remaining do I have on the capacity? How much capacity remaining do I have? What's the recommended size for workloads? And then what's the sort of the recommended total capacity as well? Um, and so what I'll do is just do a quick demonstration on looking at that capacity, and then we'll look at how that capacity is calculated. So just give me a second while I switch screens. Um, Hopefully you can see my screen.
Yeah,
Realize
that's good, Chris.
it's a little bit boxy maybe, but essentially, so I'm just logging into a live environment with our operations um, running in the background there. So we're going to do most of the work today and looking at this mostly in the capacity tab of our operations. And when we look at capacity, as you can see, depending on how much infrastructure you have, depending on how many things you see here, but we've got a data center level um, uh, um, plan there, and then these ones are sort of that's critical, and then we've got other sort of objects that we can look at as well. So when we look at this sort of capacity of this particular data center, and it could be a custom data center, it might be a full data center, we can start to see how much capacity we have remaining based on typically demand, which is the out of the box metrics, but this environment has allocation enabled as well. And we'll sort of talk about that in a little bit more depth in a minute. But essentially, we can see based on historic trends, um, and we can see this environment hasn't been up for that long. Oops, my mouse just died on me. Go back, sorry. Um, uh, we can see we can change whether it's a month, 2 months, 6 months, up to 12 months. This environment hasn't been around too long, so I'm not going to worry about changing that. And then we can forecast in the future as well. So we use the forecast based on the analytics and the capacity engine to forecast how long you have left of capacity, and it's based on the use of an algorithm called exponential decay, which essentially says all the metrics are relevant. So as you're collecting those capacity metrics, they're all relevant, but things that are further away from today are less relevant than the things that are closer to today. So something that's happening in your workload 12 months ago, maybe your workload pattern might have changed, and so it's much better to have to have those inform the capacity decisions or the capacity forecasting. But the things that have happened in the last months are a much better forecast from a metrics perspective. I'm using my mouth. It's just, and I can forecast anything up to 12 months. In the future, we'll leave it at 3 months for now. But essentially, what we can see is this is now. This line, as we can see, is the day right now. And what we're saying is, or what this is telling me is that based on demand, which is how much information or capacity I'm actually consuming in that cluster, I'm going to run out of capacity on June the 3rd from a CPU perspective. And from a memory perspective, I can see that today again the 30th, and this line here along top is the usable capacity, and so when that threshold crosses that line, that's when it's going to tell me that I'm running out of capacity from a memory perspective. So right now, this cluster itself is CPU constrained because that's going to run out first. Now, that's based on all the sort of policy settings that we put in place, and those can be tweaked and adjusted based on your risk profiles as an organization. So we can be a lot more conservative or a lot more aggressive in terms of capacity forecasting. So we can change how the metrics display, not necessarily change the metrics, but if we had a more conservative, oh sorry, more aggressive view of CPU as an example, that may push uh, the where it crosses the upper bounds crosses the line further along. And in fact, if we switch to conservative, what you'll see is it uses this mean line here, which is the one in the middle. So if I switch this cluster to use a conservative view, actually my cluster would run out there based on current trends. Now, that means that right now I probably need to start looking at putting more hardware in my environment to do that. And so you can start to see over time how that capacity run. I mean, for example, this one, it might be that I want to move workloads between clusters. So I've got this cluster here that has got no issues at all. So it's hardly doing anything. And obviously that first cluster is where we're deploying all the workloads in our demo environments at the moment. So we can see, again, from a demand perspective, this is hardly anything running in it by the looks of it, and everything is running in here. And I can tell you that this is actually running quite a lot of holodeck implementations, I believe, which is why it's seeing this utilization coming really quickly. What we can also do is and to make I said I'll come back to allocation, and allocation is essentially the other capacity model that you can use. It's not enabled by default, but you can use allocation to be able to say to, to be able to say I've got let's say 20 cores in my server, and I think, or I want to run my workloads or my environment at 10 virtual CPUs per core. So you actually physically state what you're going to do rather than allowing the sort of like the workloads and the demand model to say, well, this is what's actually happening. And so what you tend to see with allocation, and if we take sort of memory allocation versus memory demand, is that I think this is set at the moment to 10 times the amount of memory that I've actually got. So that pushes the projected forecast for when I'm going to run out of capacity a lot further than, for example, in the demand model, which is telling me, oh, it's 4 times this. It's the maximum is 150, and in the allocation it's 600, so that's 4 times. So for every 1 GB, I'm saying actually in an allocation, pretend I've got 4 GB of memory, and so that pushes my usable capacity over, and therefore, from an allocation perspective, I can have a lot more runway to be able to extend my environment. Now, that isn't always the best thing to do, but you can do that in that perspective. You just need to ensure that you've got the right measure of how much you're willing to allocate per CPU if you're using the allocation model. Personally, the demand model is a lot more accurate in that respect, and typically we see service providers using allocation model to be able to sweat assets typically. Okay, so let's have a look. Switch back to the presentation. 1 second. So again, slides are in there, and we talked about that. And we'll have a look at the policy in a second. And so essentially what you can do is you can drive the behavior differently based on the clusters that you have. So it doesn't all have to be the same for every cluster. You can use operations policies to assign different allocation models. So for some clusters, the allocation model might be on, and some others it won't be. You can also set the the different thresholds and the different conservative or aggressiveness of the forecasting engine or the capacity engine, as it says here. So again, so you can, as you change the conservativeness of the policy, whether that be aggressive, that would push um, this line out further to the right hand side in your capacity planning, and conservative would bring it in closer to the mod the where we are right now. Because what conservative is doing is saying actually, let's be a little bit conservative about how much capacity we have, so that we alert people in enough time for them to be able to either do some right sizing or reclamation, or to buy new hardware and get that in place to be able to extend the capacity. Okay, so when we're looking at sort of time remaining, the values as we sort of saw there, whether it's got over a year left remaining, or 30 days, or 5 days, or whatever, that's based on all what the capacity engine calculates. And what you can see here is essentially the current time in this graph is now, and based on the trend that's happening of capacity, and it's a stylized trend, you'll have an upper bound from the projection perspective. So anything for the right of this line here is just us using analytics from history and periodic algorithms and linear algorithms to work out what we think the projection is going to be. So we have an upper bound, and then we have a lower bounds, and then we have this mean average projection. So when you move further and further into the conservative way of projection, you switch to saying, well, actually, my time remaining is the upper bounds, because that's what crosses the line first, because that's above the mean average. And that could change your projection from anything from a year down to a few days, depending on how your workloads are running. And then the same with capacity. So we can look at the way that we look at when we look at that capacity remaining metric. We can actually say that Again, we use when we're doing conservative capacity planning, we use the upper bounds and we say that the capacity remaining, and this line across the top here is this usable capacity. So this is 0 at the bottom, and this is our usable capacity within the cluster across that line there. And the workloads and the capacity being consumed by the cluster is the wavy line. The capacity remaining is actually not how much is remaining today. It's actually how much would, based on the forecast, how much would be available in 3 days' time. So this is why you see this dotted line. So it's current time plus 3 days, and it's the difference between the upper bound capacity and the actual usable capacity line. So that's how much capacity is available, and that's how we calculate that metric. So as you see, capacity remaining values within the dashboards or within the interface, that's how it's calculated. We then have sort of recommended size, and again, it's calculated, or the recommended size of a cluster or a workload, and that's the blue line here, and that's based on 30 days from where this time remaining occurs. So where the upper bound, so the projection goes from today to 30 days, and where that the upper bound then hits that 30-day limit is where we get the recommended size for a particular cluster. So maybe, or a workload, it may be up, maybe down, but that's how we work the recommended size. And then finally, the total capacity is based again on this 30-day limit, and that's the essentially taking the usable capacity from a recommended perspective, recommended usable capacity, and then adding back in the HA and buffer. So this is usable capacity without HA and buffer, the line along the bottom here, as I'm showing. Hopefully you can see on my maybe you can, maybe you can't, but the usable capacity. And then the recommended size is the first dotted line across, and then the total capacity recommended, which is recommended usable capacity plus the HAM buffer. Now, realize that's probably gone really low level very quickly, but when you're looking at capacity planning, you need to understand those concepts and how we do things to look at that. And as I said, when we look at capacity, we use that sort of capacity engine, and we use this theory of the exponential decay, which says we take all of the metrics into consideration, but the things that happen closest to the middle vertical line there, which is the current time, are more important than the things that start at the start of the projection. We also take into consideration peaks. So where we looked at that the demo, and we saw the balloon, if you like, around the forecast, which gave us the upper model and the lower model. We use the peaks to determine what that looks like. And depending on whether they're momentary peaks, we tend to ignore momentary peaks because they don't necessarily have any impact. They could be one-off. If they happen for a sustained period of time, that will impact the bubble shape that you see on that capacity model. And if they're periodic, up and down, up and down, up and down on a regular interval, then again, that will affect the way that bubble forecast, the upper bounds and the lower bounds changes around the median. We can also change our through policy, we can also change it to be peak focused. So what tends to happen when you're not peak focused is it takes the upper bound, the upper peak and the lower peak, and it does that mean average, and it uses the mean average to do things. Where if you have workloads that are peaky and you want to concentrate on the peaks, then you can tick the button, and that will do the forecast based on those peaks rather than the average between the trough and the peak. So again, really depends on what you're doing from and how your business wants to run their capacity. Finally, another setting which we'll have a look in the policies in a second is business hours. Business hours can be really important because what tends to happen is if your business runs Monday to Friday 9 to 5, and doesn't, and these workloads do nothing at the weekend, that skews the capacity forecast because for 2 out of 7 days, utilization is near zero. So when it's 60, 80% during the week and then zero for 2 days, that might be the average might be 60, 50%. Whereas when you enable business hours in the product, you can say, well, do my capacity calculations between these times. So Monday to Friday, and you can do it into hours as well. You can just do days, and say, well, actually, maybe Monday to Friday, 9 to 5. I don't. Nothing runs after, let's say, 6 o'clock or before 8 o'clock. So let's do it actually 8 till 6, and that's when I want you to take my capacity metrics to inform my capacity forecast. And again, that because it's policy setting can be done against different workload domains or different clusters based on the workloads you're having in there. And what it does essentially is it increases the average time because you're not taking into your average metric, sorry, because you're not taking into consideration all the lowest time when you're not doing anything. So it may be good from a development perspective if you're not doing anything at the weekend and you want to maintain your capacity forecast for your development environment, so you know when to add hosts, and that development only happens, during sort of Monday to Friday. Then you can enable business hours on that, so that you don't run out of capacity sooner than you should do. And it may be that the rest of your operations run 24/7, and you don't need to worry about business hours. Okay, so let's switch back to the demo environment to have a quick look at what that looks like in the policy. Um, okay, so what we can do is we can go into this is the only time we're going to probably jump out of that capacity thing. We're going to look at configuration, we're going to look at policy definitions. And policies in ops are a bit like Active Directory policies, they're hierarchical. So in our environment here, we've got a default policy and we've got our lab default policy. And underneath that, we've got a couple of policies. And so I created this one earlier. Essentially, you can edit the policy and you can look at the capacity and you can look at the risk level. So you can say, well, for this cluster, I want to be really conservative or I want to be really aggressive. It depends on how you want to do that. And again, aggressive means you're going to sweat that asset a little bit more, you're not, and you're going to wait, increase that projection line. Whereas conservative would mean actually tell me sooner that I need capacity, so I've got time to be able to, order new servers, put the servers in the data center, configure them, into a workload domain, and therefore, or add the host into the workload domain. And again, the peak focus you can do there as well, to worry about peaks. And again, depending on the capacity, peaks may be an issue, may not be an issue, but it's definitely there to choose. You can then do, as I said, those business hours. You can then sort of enable those, and you can do that, Monday to Friday if you want to for particular times, and you can base it on host time or NTP. Um, and then you can look at um, capacity settings. So this is enabling an allocation model. So as you saw, we've got a CPU and memory allocation model enabled, and we're doing 4 to 1. If I wanted to, I could make that 40 to 1. I could make it 4,000 to 1. I could make it anything I like, and that's why it can be very dangerous because you can. No matter what happens, capacity isn't magic. Okay, when you've run out of capacity, you run out of capacity. What we're doing in the allocation model is almost falsifying how much capacity you have left. And so you have to do it, if you're going to do it, you have to do it with the knowledge of what you want to do. So don't just go, oh yeah, I can do 1,000 CPUs per vCPU because that's not going to work. Because at the end of the day, when the capacity runs out, it runs out. You're just not going to be notified. So make it sensible. You can do that on data store and data store clusters as well. And then you also, again, you can configure, the capacity buffer based on even on allocation demand for CPU, memory, and disk as well. So this is that the buffer with the HA we talked about earlier. And then you can start to, if you wanted to, sorry, scroll happy today, you can start to change when thresholds get alerted. Now, I don't necessarily tend to recommend this, but different organizations will have different policies and different, ways of doing things. So you can change when you're alerted, whether it be when there's 90 days remaining, 120 days remaining, you can choose how you do that. If you want to add another intermediate step, you can add another intermediate step. It really depends on what your business is like, and so if it takes, for example, let's say 5 months to commission a host, you probably want to know that you're gonna run out in 5 months' time. So you might change the warning setting to 5 months. So let's say 150 days as an example, so that you're warned, and then you can start off the procurement process. And then as you go through that procurement process, you could do reclamation, you could do right sizing to get some capacity back, but at least you've got that trigger around being able to start that procurement process for new hardware. And it could be that you're being warned of capacity. You might move hosts around. You might be, well, actually, I'm 90% capacity in one cluster, but I'm 20% capacity in another. Let's move a host from that cluster to the one that needs it, and then backfill the other cluster that doesn't have that capacity constraints, and therefore you're almost deferring that as well. So lots of things you can do based on process. So time remaining, capacity remaining, you can change when you're alerted if you want to. And again, when you make those changes to the policy, um, you can choose which groups or objects, whether it be a custom group or just vCenter objects, that you want to apply that to. Typically, again, it's done at a cluster level, or a data center level, but typically it's a cluster level when we're talking about capacity. And as I said, I signed that to that one earlier on. Okay, switch back to the presentation. I'm hoping that my colleagues are answering all the questions in the background and there isn't anything to me to answer later. Um, okay, fabulous. Um, Okay, so now we have the ability. So once we've looked at, we've assessed the capacity, we know what we've got going, we know how much we've got left, how much time we've got left, we know how much capacity we've got left, we know when it's going to run out. We can do that on demand or we can do that on allocation. It really depends on what we want to do. For me personally, the preference is demand because that's more realistic. Demand is I'm using 2 GHz. Allocation is I've got two CPUs. So it's unrealistic from that perspective, but there is reasons for doing the allocation model. So switch back again to my demo. So we're going to look at reclaiming capacity and how we can um, reclaim some of those things that we've got in our environment that maybe we don't know, because really, when we think about capacity planning, we want to think about capacity forecasting. It's about how can I change my um, uh, practices and look at holistically my environment to see if I can reclaim lots and lots of capacity. I don't need to buy hosts. And contrary to popular belief, I would like you to buy hosts when you want hosts, not when someone tells you need it and when you don't need it. So let me just switch back to the environment again. Um, so we're going to go back into this capacity section and we're going to look at reclaim. So reclaim, we do 4 things. We tell you when there's powered off VMs. Now, as you can see here, because I've got costing configured, I can see the relative cost that I might save from that. But I can start to see, I've got a number of powered off VMs across my environment, filling up quite a lot of storage. Now it's a little bit we're in the middle of migrating stuff around, so this is a little bit that's a 52 terabyte virtual machine by the looks of it, but essentially we've got lots of things running in our environment that we could reclaim capacity. Powered off VMs, sorry, and we could reclaim that capacity because it's not necessarily whilst powered off VMs don't affect, unless we tell it to, it doesn't affect CPU and memory capacity, it does affect disk capacity. So it's about putting off the need to buy new disk arrays, maybe new hosts if you're using vSAN. You're trying to reclaim as much capacity, whether it be CPU, memory, or disk, as possible. And we can see that there's quite a few machines there that can be reclaimed. Maybe this one here, it's there for a reason, I don't know why. But what we can do is we can exclude that VM from the list so that we're not told about it again. But it's here. If we want to have a look at it, we can have a look at those excluded VMs. So we can see now we've got these two. What I can do if I want to, if I have the power to, and I have the rights, and there's an action account that has the ability to do it, then I could, if I wanted to, delete that VM right now. Now, by default, our operations doesn't need a privileged account to be able to do things to an environment. It's a read mechanism. It reads the data, it does all the capacity analytics within the platform, and gives you recommendations. Now, when you configure your accounts to connect to vCenter or VCF, then there is in advanced options, there's an ability to do an action account, and that action account needs privileges to work. So if you've got an action account configured, or your account that you're using to connect to vCenter does have extended privileges, then you could go and delete that VM now. I'm not going to go and delete it because I don't know what that's there for. As I said, we're running quite a lot of holodeck environments within this environment as well. So I can click all of those and go, I just delete. Or actually, I could schedule it using Automation Central to happen on a particular time and day. It's not happening now. Um, I can export that to a list as well. But really, from a reclamation perspective, it's all about being able to have that conversation with your end users to say, we deployed this machine for you, but it's been powered off for a month. Are you using it? If not, can we remove it? Um, and what you can do is you can decide when things turn up in here. Before we move on to idle machines and snapshots, you can set the settings. So you can say, well, whether I want to show costs or not, that's enabled. Now, tell me about powered off VMs when they've been powered off for more than 7 days. Okay. Tell me about idle VMs when they're at least 7 days, but don't tell me about them for the first 30 days because maybe I've deployed a virtual machine for a project sooner than they're really ready for it. We give them 30 days worth of leeway before, in fact, 37 days worth of leeway before I start reporting on the fact that's idle. And those, I think, are the defaults out of the box. And so you can change those to whatever your business is going to be, whatever policies you want to follow from a business perspective. Snapshots older than 7 days. Maybe you want snapshots older than a day or a month. It really depends on what you want to do. And then orphan disks older than 30 days. And that, again, configurable. And that's across the piece rather than for a particular cluster. So then I can look at idle VMs, I can look at powered off VMs. I can see, potentially how much cost I can reclaim, how much CPUs are reclaimable, how much memory is reclaimable. Because while it's powered off, it's only consuming disk, but when it's powered on, it's consuming CPU and memory resources, and so that is all adding to my reduction in usable capacity for workloads that need it. So again, it tells you how long it's been idle for. Idle in our environment is set to 100 megahertz 100% of the time. Again, customizable. It maybe you want 300 megahertz or 50% of the time. It really depends on, again, what your business process procedures and strategies say. And again, I can exclude the ones that may be there for a reason. I can't really think of a reason why an idle machine wouldn't need to be removed. Again, apart from the fact that you put it there for a project and they're not ready to consume it. And this is across all data centers, right? So I can click on the different data centers and I can see that it's not just on a particular single vCenter. It could be a custom data center that goes across multiple vCenters. I can then look at snapshots, and here I could reclaim 4.9 terabytes worth of storage by removing these snapshots for these virtual machines. Now, there may be a reason they're there, but maybe my policy says I'm only allowed 7 days. So I don't really mind or I don't really care why they're there. It's a conversation point with whoever owns these virtual machines to say, look, our snapshot policy is 7 days. You've had it for 60 days. The snapshot's probably bigger than the virtual machine is. I think we need to delete it. and so start to reclaim that capacity as well. Because if that disk is again the ESXi is an embedded ESXi host, if that ESXi host is 1 terabyte, you can reclaim 1.26 terabytes. So that's currently a 2.26 terabyte ESXi host because of the snapshot. So it's a lot of capacity you could reclaim. Orphan disks are there as well. Again, quite a lot of capacity. This is the bottom one there. I know is a disk array we put in there to be able to migrate data when we rebuilt the environment. So I know why that's there. But as you'll note, with all of these three other ones, I can schedule, I can delete right now if I want to, and I can exclude the VMs. But with orphan disks, I can exclude the disk, but I can't delete them. I can export them because there may be a reason, and typically an orphan disk is there because you're looking, or you've created a virtual machine, you've added another disk, it hasn't put it into the same folder, you've deleted the virtual machine, and it hasn't deleted the other folder with the disk in it, and therefore it's just sitting there doing nothing. It's not attached to anything, it's just there. So what we do is give you the ability to export those to a CSV file for you to go and investigate why that's there. And again, if we did all of that stuff, we could reclaim 36 virtual machines or resources for 36 virtual machines, 269 orphan disks, with our environment saving around about €3,500 a month because it's based in EMEA, and 22 vCPUs, 28 gigs of RAM, 40 terabytes of disk. It's a relatively new environment and not got a lot of workloads in it. So depending on your environment, that could be quite a lot of space that you can reclaim. Right size is another one. I'm not going to go back to the presentation because I know right size is next. And again, you'll hopefully get the presentation, or we'll hopefully make sure it's downloadable for you. And so when I look at right size, so this is about not removing capacity or removing virtual machines. It's about making sure that the machines that are there and they're running are at the right size and shape. Because if you've got too much capacity, that's a bad thing from a virtualization perspective. If you haven't got enough capacity, that's a bad thing from an application and a service perspective. And it really does start to start those conversations with businesses. It's a very difficult conversation to have. I want to take lots of stuff away from you, Mr. Business Owner, because we can make your environment run more efficiently. But typically, there is the business owner was like, "Well, I'm paying for those resources, so why do you need to take them away from me?" And not really understanding that actually the environment or the applications would run better for it. And typically, I tend to make the conversation around. Um, Here's some stuff we want to take away, but here's some stuff we want to add. Because typically, that when you look at an application, that's what you tend to see. You tend to see some resources that are being underutilized and some resources that are being overutilized. So you can sort of balance that out. And again, just like with sort of the reclamation, I can look at my oversized virtual machines and I can say, well, this machine here is allocated 24 vCPUs, and the recommended reduction is 12 vCPUs. Now, it's only 12 vCPUs because the maximum we will recommend a reduction is 50%. So that could actually be a machine that needs to be 4 CPUs, but we restrict what we recommend to 50% of the allocated. Um, so you'll only ever see this as being a maximum as half. And same with the memory, but as you can see here, it's not quite half. It's we recommend you reduce it by around about 100 gigabytes. And again, if you're brave, you can click all of them or some of them and click resize VMs. It's disruptive. It will reboot. It will cause problems. Don't do it. You can schedule it. Again, using Automation Central. You can also do scheduled jobs within Automation Central to allow you to tag particular workloads, as maybe a resize that, and then have that scheduled job run every month. And then when it just before it does the job, it looks for all of those tags that you've asked it to look for, and then resizes the workloads based on tags as well. So again, conversation points. Same with undersized. We've got some undersized VMs maybe, if I have. Yep. So 16 allocated. I don't need to add any more. but this one's got 128 gigs of RAM, and we think it needs another 126 gigs of RAM. Again, this is a holodeck environment, which is basically a VCF instance embedded for demo purposes. So you can see that memory CPUs seem to be fine, but memory could do with a little bit more memory, and that's where it becomes that trade-off. Or this web server that's got 8 CPUs and 28 gigs of RAM doesn't need that much. Maybe it needs 2 CPUs and 4 gigs of RAM. But your database server that's got 4 CPUs and 16 gig of RAM maybe needs 32 or 64 gigs of RAM. So we're going to take some away from your web servers, add some into your database servers, and whilst your resources won't necessarily go up or down too much, your resource allocation, your spread will be a lot better, and your application will work a lot better. That tends to be the sort of conversation I have with customers. Finally, we can do something called workload placement, which is enabling us to put the workloads in the right location, but then also run a placement engine to make sure that we're optimally putting workloads and moving workloads based on the things that we want. Um, so by default, it's done a sort of moderate. And so essentially what happens is in moderate, nothing changes unless there's a known issue that's going to happen. Because from a resource utilization perspective, we get to learn what the new normal is from a resource perspective. So, if that workload runs really busy on a Friday afternoon because it's doing payroll once a month, then let's move a workload away from that, or workloads away from that, so that it has enough capacity to do that, or move that workload somewhere else in the cluster so it has capacity to do that. But only do it when we know there's going to be an issue, and that's what moderate does. We can change that setting to balance, so constantly move things around my cluster to make sure I'm utilizing the capacity of my cluster in the most efficient way, and my risk is minimized around the host failure. Or I could consolidate and say, well, actually, my cluster's running at 25% utilization. I don't need all of those hosts in that cluster because I've got a cluster over here that's running at 85% utilization. So I want to take one of the hosts out and I want to put it into another cluster. So with the consolidate option, I can pull back all of the virtual machines into as minimal hosts as possible, based on HA as well. Making sure those constraints are met, and then give me capacity to remove that host and put it somewhere else. I can add cluster headroom if I want to. So on top of buffer, which we talked about earlier, the cluster headroom will allow me to give up to 50% of my cluster to be able to, if I'm a risk adverse organization. And then you can also use and make sure that, because obviously as you migrate workloads around, typically distributed switches are across the piece from a cluster perspective. But that setting there, the target network policy settings, makes sure that the host that I'm going to move to can also provide the networking capabilities that I'm expecting for the workload. I can also do business intent. Business intent allows me to do tag-based placement of workloads. I want my Windows workloads on this cluster. I want my all other workloads on this cluster, or I want my database workloads on this cluster because that's where I'm licensing my database software, and all other applications on a different cluster. And that's so we tag the workload, we tag the hosts, and it basically manages VM host group rules a centralized way. And you can see, the utilization of the workloads here. You can run your operational intent in 3 different ways. You can do it now. You can schedule it to happen every day, week, month, or you can run it automatically. That requires fully automated DRS to move stuff around to do that, though. Finally, capacity forecast. So what happens when I want to add workloads to my environment, and how does that impact? So we split into two. So we have workload planning, adding virtual machines for traditional workloads, so your physical hosts with external storage, and then your hyperconverged hosts, so vSAN clusters essentially. And I think our environment is all vSAN based. Uh, yeah. So if it wasn't vSAN based, you wouldn't be able to see. So you can add um, virtual machines to a particular cluster. This is a workload domain, and then any cluster in that workload domain, or I can choose a particular cluster. So let's say cluster one. I can choose the configuration if I want to. Maybe I've been given some recommendations from the application vendor about what CPU memory and disk utilization I have, or if it's I just want to deploy the application again, maybe it's already existing and I can take the information from the vCenter already, knowing what is available to me. So let's say I want to add all of those virtual machines into my cluster. So it copies it across, and you've got the allocation, you've got the demand metrics that we can use to inform in a much better way than using the configuration. Now, import custom profile is that you can create, small, medium, large custom profiles within the product, so that you can then use those if you want to. So, how many large machines can I have left, or what happens if I add 30 medium machines? You can do that too. And then so you can add all those machines. You can change the quantity if you want to, and then you can run the scenario, and then it'll tell you if I've got to do anything to my cluster to be able to have those workloads running. Let's give that a couple of seconds. I think it looks all right at the moment, which is good. So what it's saying is if I added all of those workloads in, it would cost me about £547 a month. But after I did all that, sorry, euros. After I did all that, I'd still have over a year's worth of remaining capacity. And if I want to, and I'm ready for that, I can commit that scenario. And when I commit that scenario, that means the next time I come and do another scenario, it will take my current capacity plus all of my committed scenarios, and then the new scenario that I've added, so that you're basically committing that capacity, even though it's not actually being used right now, from a forecasting perspective. Um, so I can commit that, and on a particular day a month, and I can commit that capacity if I want to. I'm going to save that one for the moment. I'm going to go back into my what if scenarios, and let's say um, I wanted to add an HCI node at the same time. So it's nodes. Um, um, Sorry, my network's playing up today. Right, so I can do a workload domain again. I'm going to choose the same cluster I chose before. I'm going to select my server type. Now, um, if your server type's not there, you can actually create your own server types as well. But essentially, because we're connected to vCenter, we know what the ESXi hosts are. Typically, you want the same host that you're adding. Especially from a vSAN perspective, this is a vSAN cluster. Maybe I want to add one or two nodes at this particular time. And then again, I can run that scenario. And I know I've got capacity because I've just added a bunch of machines. Um, but and it didn't blink an eyelid. But what it'll do when I add capacity is, and then it says, well, actually, um, this is what's going to happen to my capacity if I do that. Oops. Um, and again, it'll start to see what's happening. Maybe I should have chosen a different cluster to add the capacity to. But you can start to see what's going to happen, from a CPU demand and memory demand perspective. I've already got lots of white space, so I'm just going to add more white space. If I added it to the right cluster, let's change it to cluster two. Uh, it's got different servers in it, so let's just choose that model. Oops, sorry. Leader, maybe it's the next one. Can't remember which cluster was the one with the capacity issue. Oh, okay, so let's save that scenario. So again, I can commit the scenario if I want to, but what I can also do is I can go to what if scenarios. I can got these save scenarios, and I can run them. But if I was having capacity problems and I wanted to add machines, maybe what I want to do is I want to replace machines or replace physical servers. So what I can do is I could create a remove host and an add host. Maybe I want to remove the host I've got and then I want to add some new hosts that are bigger and better to see how many sort of hosts I need. Um, so I should, why can't it's because I'm different this now on different clusters. Let's just edit that a second. Switch that back to cluster one. Oh, change the server type. Apologies. Save the scenario. So once I've got those, I can then run them together. So I can see what happens if I want to add machines and add hosts, or remove machines. Maybe I want to add machines and I will remove hosts. Again, because I'm maybe consolidating to see what I'm doing. Now, as we sort of sell, there's quite a lot of capacity left, so it's not a problem. Okay, so let's switch back to the presentation. Okay, so we've talked through all of that. We did capacity, we did forecast, we did that. So the last thing to talk about is just some resources. There are, as I said at the start, there's some hands-on labs out there already for VCF 5.2. So operations getting started, getting more out of becoming a power user, and essentially operations is sorry, the hands-on labs is that sandbox environment you can go and play with things without breaking things. And then there's some, if you're interested in following people and articles they do, there's some colleagues of mine, both in EMEA and the US, who have blogs out there that talk about all the new features and the capabilities. And then finally, there is a free book out there on the VMware Ops Guide, which is written by a gentleman called Ewan, who essentially is the godfather of ops metrics. So yeah, thank you very much.
Well, thank you, Chris. If you just flick through to the next slide. So yeah, that was great. I'm just conscious that I know we ran over slightly, but there was a lot of content there. So thank you, Chris, and I think the demo gods worked for us today. So yeah, really appreciate that. So as usual, at the end of the session, if you can please fill in the survey, that's really important to us for choosing the topic for the next webinar, which will be on Friday, the 27th of June. So during next week, we'll upload the recording to the registration page, which I think I posted it in the chat, in case you're looking for that and you want to go back and look over what Chris took us through. I also want to call out the next or this year's VMUG user conference, which will be in the Hilton Metropole, London, on the 18th of September. There will be the usual V beers, V curries, and the famous V quiz the night before. You do need to register to be able to get access to that. So um, please either just use the URL, which I will just post in the chat, or just take a picture of the QR code. So just bear with me whilst I post the link. Um, Highly recommend trying to get registrations in there as soon as possible. I think given the fact that it's the day after the Explore on Tour is going to be high demand, so I would suggest getting into and getting registered on that ASAP. The other thing on that is if you've got a particular piece of work or a project you've been working on built on VMware technologies, and you've done something which you're really proud of and which took a lot of effort, you really want to share it with the community, then we've got the call of papers which are open. So just follow that link, or again use the QR code. So again, thank you very much for joining us today. On behalf of the UK&I Solution Architecture team, thank you very much for joining us, and we will see you in a month's time. So have a good weekend and goodbye.